Welcome to True Projects. In this video, we are going to explain about the project, which is Sliding Window Blockchain Architecture for Internet of Things. Introduction of the project. IoT devices are physical objects with sensors and internet connectivity, enabling data collection and automation in various domains like home automation, healthcare, and more. IoT devices generate extensive data through sensors and connectivity, enabling data-driven insights across diverse applications and industries. In traditional methods, IoT data is often stored in centralized servers. This centralization poses security risks as a single point of failure that could compromise all the data. Additionally, verifying the integrity of data across all the nodes can be computationally intensive, making it unsuitable for IoT devices with limited resources. The project uses blockchain for decentralized data storage, improving security by distributing data across multiple nodes. It employs the sliding window technique to reduce memory and processing overhead during the blockchain verification for resource-constrained IoT devices, ensuring data integrity. An energy-saving extension algorithm is introduced to optimize IoT device performance by eliminating duplicate data within a specific time frame, reducing energy consumption and processing time. The sliding window technique is a method for handling a restricted number of the most recent blockchain transaction hash values, which serves to minimize memory and processing demands on IoT devices. By focusing on a limited yet relevant set of recent transactions, it efficiently manages data without overwhelming the device's resources. Blockchain is a digital ledger that operates in a decentralized manner, recording and validating transactions across a computer network, which guarantees security, transparency, and immutability of the recorded data. It offers a reliable and tamper-resistant way to maintain transaction records and information. The primary objective is to improve the security of Internet of Things devices by implementing blockchain technology for decentralized data storage, reducing the risk of data breaches. Implementing the sliding window technique to efficiently manage blockchain transactions, reducing the memory and processing overhead, particularly on resource-constrained IoT devices. Developing an energy-saving extension algorithm to avoid storing duplicate data generated within specific time intervals, leading to significant energy conservation in IoT operations. Adapting the project for simulation to overcome the lack of physical IoT devices, ensuring that the proposed security and energy-saving measures can be tested and evaluated. To implement this project, we need hardware and software requirements. Coming to the hardware requirements, we need processor of 5 and above, RAM of 8 GB and above, and ROM of 25 GB and above. Coming to software requirements, we need Node.js, Python of 3.7.0, and Visual Studio Community version. To implement this project, we have designed various modules in the methodology. The first module is Create Smart Home IoT Network. In this module, the user initiates the creation of a smart home Internet of Things network. This involves setting up the environment where IoT devices will operate and send data. The network may consist of virtual or simulated IoT devices and the parameters such as the number of devices and their characteristics that can be configured at this stage. The next module is Run SWBC Simulation. This module involves the execution of the sliding window blockchain simulation. It allows that the IoT devices within the network to sense data randomly and generate transactions. The simulation monitors and records the data sensing, encryption, and blockchain operations such as mining. It provides insights into how the blockchain system manages data under different scenarios. Coming to the next module, which is Run SWBC Extension Algorithm. This module extends the simulation by running the energy-saving extension algorithm. This algorithm monitors data generated by IoT devices within specific time intervals and prevents the storage of duplicate data. By doing so, it conserves energy resources and reduces processing overhead. The module demonstrates the efficiency of this algorithm in practice. Coming to the comparison graph module, after executing the simulation and extension algorithm, the comparison graph module provides a visual representation of the results. It typically displays a graph that compares the number of packets processed without extension algorithm. This graph helps illustrating the energy-saving benefits of the extension algorithm in the context of the SWBC simulation. Blockchain integration. The blockchain integration safeguards IoT data by decentralizing storage, eliminating the vulnerability of a single point of failure. Blockchain integration includes the generation of transaction hash values for IoT data, preserving data integrity, and preventing unauthorized modifications. The project's blockchain integration encompasses block creation, transaction hash management within a sliding window, and verification, optimizing IoT data management. Blockchain is integrated into the energy-saving extension algorithm to monitor and prevent duplicate data storage, preserving IoT device energy resources. For execution of the project, first we need to open the code folder which contains source code files. This is the code folder of the project, and here we have run.bat file. Instead of executing the project through command line interface, we have created Windows batch file. Now we need to double click on it to execute the project. So here we can see the user interface of the project. With this we can interact with the program, and this is created by using the Tkinter library. From the packet transfer drop-down, I'm selecting 15 as a packet transfer. From the window size drop-down, I'm selecting 5 as a window size. Now I'm clicking on Create Smart Home IoT Network. As we have selected 15 as a packet transfer and the window size as 5, which means a blockchain can store data up to 5 blocks, and if exceeded, then old block will be removed out and sent to cloud for storage. And new block will be stored in IoT memory. Here we can see that all the red color circles are the home IoT and the blue color circle is the IoT cloud, which will receive data from IoT upon IoT window. Now we will click on Run SWBC Simulation button to allow each circle to sense data randomly. So I'm clicking on Run SWBC Simulation. Here we can see that IoT labels are sensing data and its label color is being changed to red color. And this simulation will run for 15 packets transfer, and for each transfer, sensors will be chosen randomly. After sending packets, here we receive the dialog box. Here we can see that total transfer packets are 15 and the total execution time for window size 5. And now we will click on OK. Here we can see that as our window size was 5, the first block is empty for all Genesis, and latest 4 records of IoT are displayed. In the first column we can see encrypted packet, in the next column we can see decrypted packet, here we can see previous hash code, and here we can see packet index, current hash and timestamp. And here we can see that current hash of the index 7 is being matched with the previous hash of packet index 8. Now we will get back to the user interface. So here in the text area, we can see that which IoT is sensing data and its sense value separated by comma symbol. In the next line, displaying AES encrypted data and then displaying mining is done or not. With proposed work, we sense and store 15 packets, and sometime IoT sensor will sense same data as temperature will not change for same interval. If we send same data again and again, then it wastes processing time and increase overhead. To overcome this, we are using extension algorithm. So now we need to click on Run SWBC Simulation Extension Algorithm button to avoid duplicate processing. So I'm clicking on this. So here we can see that IoT started sensing and sending packets in IoT numbers, and they are being changed to red color, which means it is sensing and sending data. After 15 packets transformation, with the extension work from 15 packets, we process 15 packets and the duplicate packets are avoided. Here in this, we can see that 5 packets energy consumption is saved. Now we will close this and click on comparison graph. So here we can see that x-axis represents algorithm names and y-axis represents number of packets transferred. So here we can see that extension work application process only 10 packets and saving 5 packets energy. Conclusion of the project. The project successfully demonstrates the potential of blockchain technology in enhancing the security and data integrity of Internet of Things devices by decentralizing data storage. The integration of sliding window blockchain technique optimizes memory and processing resources, ensuring efficient management of IoT data. The energy-saving extension algorithm effectively reduces energy consumption by monitoring and avoiding storage of duplicate data, further improving the sustainability of IoT operations. The project simulation and graphical comparison illustrates the practical benefits of these innovations, offering a promising solution for secure, resource-efficient IoT networks.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.